Finding the derivative of x to the n. Using the binomial theorem, we start by expanding x plus h to the n. So x plus h to the n is x to the n plus n x to the n minus 1 times h plus n minus 1 over 2 x to the n minus 2 h squared, and so on. And note here that n is just nc1 and n minus 1 over 2 is nc2. So it's exactly the binomial theorem as we're used to. And we can now use the formula that f dashed x is the limit as h tends to 0 of f of x plus h minus f of x over h. So that gives us the limit as h tends to 0 of x to the n plus n x to the n minus 1 h plus n minus 1 over 2 x to the n minus 2 h squared, and so on. Now let's just think about this. So we're looking at a curve here. So that this point here is the point x, and since we're looking at x to the n would be the y coordinate, and then we have x plus h, and the y coordinate is x plus h to the n. So this is the curve y equals x to the n. So this is the first few terms of x plus h to the n, and then we need to take away f of x, which would just be x to the n in this case, and all of that is over h. So that's going to be the limit as h tends to 0. Well, the x to the n here will cancel with this one here, and then once we've done that, we can divide everything on the top by h. So this term here will be n x to the n minus 1, and then this term will be n minus 1 over 2 x to the n minus 2 h, and the next term after that would have an h squared, so we'll just write order h squared, and so on. Well, we're looking at h tending to 0. So what's going to happen is this term is going to tend to 0 because it has an h, and this one would tend to 0 because it's got an h squared, and so on all the way down the line. So we end up with the only term that doesn't contain an h, which is nx to the n minus 1. So if f of x is x to the n, then f dashed x, which is the first derivative of f of x, is nx to the n minus 1. So the n comes down in front of multiplies, and we reduce the power by 1. An alternative notation is if y is equal to x to the n, then dy dx is equal to nx to the n minus 1. And I have to admit that this second one is my favourite notation.